Hello friends, this is a follow-up of the first class on hybridization. In that class, in the end, I had given you an assignment where you were supposed to make structures of hybridized structures of various molecules. So let me solve that assignment for you. The first molecule which I had given you was formamide. The structure of formamide is HC double bond O NH2. So let us look at this particular structure. In this structure, first let me write the steric numbers. The carbon here has got 3 sigma bonds. So I can say that the steric number for this carbon is 3. The nitrogen, if you see, it has how many bonds? It has 1 bond with carbon and 2 bonds with hydrogen. So total, we are accounting for 6 electrons. Per bond, 2 electrons. But nitrogen should have 8 electrons. That means there has to be a lone pair which they have not drawn. Similarly, let us look at oxygen. If you see in oxygen, there are 2 bonds. That means we have 4 electrons, right? So 4 electrons can be seen, but total it should be how many? 8 electrons. So let us make 2 lone pairs again. Now let me calculate the steric number. For nitrogen, the steric number will be 3 sigma bonds plus 1 lone pair of electrons. Steric number will be 4. For oxygen, the steric number will be 1 sigma bond plus 2 lone pair of electrons. That the steric number is 3. Fine. So where it is 3, it has to be sp2 hybridized. Where it is 4, it has to be sp3 hybridized. Here it is sp2 hybridized. So now we have the hybridizations of formamide in place, and we can now proceed to make the hybridized structure. First of all, we will make the multiple bond. So carbon, as I said, is sp2. So let us first draw our sp2 hybridized carbon that I have made. Then my oxygen is again sp2. So let me make my oxygen. I made my oxygen, and now I have nitrogen which is connected to carbon, and the nitrogen is sp3. So let me connect it to carbon and make it sp3. Fine, so I've made that. Now let me change the color, and so that I can show you, this one is carbon, this one is oxygen, and this one is nitrogen. Fine. Okay, oxygen has 2 lone pair of electrons present. Carbon has on one side 1 hydrogen attached. Nitrogen has a lone pair of electron and 2 hydrogens attached. So let us write the hydrogens. Fine. Now what is left? What is left is pi bond. So let us make the pi bonds. Each of the carbons has an unhybridized p orbital. Let me make the unhybridized p orbital. So this is one unhybridized p orbital. Oxygen also has an unhybridized p orbital. Let me make that as well. So I have made the unhybridized p orbitals. And so this is the pi bond which I have created. So you can see this is the structure of formamide. Let's do the next structure now. Okay. The next structure which we had, which I had given you, was chloromethane. So what is chloromethane? CH3Cl. This is chloromethane. If you look at chloromethane, the chlorine here, I can see there is just 1 bond which they have made. That means I am accounting for 2 electrons. Total number of electrons have to be 8. So let me make the lone pairs. So we have 3 lone pairs there. Fine, this is chlorine. Now let me calculate the steric number. My carbon has 4 sigma bonds, 3 with hydrogen and 1 with chlorine. So here the steric number is 4. My chlorine also has 3 lone pair of electrons plus 1 sigma bond. So steric number is 4. That means both the atoms here are sp3 hybridized. Now we are all set to make the hybridized structure. Let me make the structure for carbon first. So this is the sp3 hybridized carbon which I have made. Now let me make the sp3 hybridized chlorine. So this is the sp3 hybridized chlorine. In chlorine, you have 3 lone pair of electrons. So let me make the 3 lone pair of electrons. On carbon, we have 3 hydrogens. Let's make the 3 hydrogens. So I made the 3 hydrogens. Now let me write carbon here and chlorine here. So this is the structure of chloromethane. I hope you have understood it, students. Let's take another structure. The next structure which I had given you was ethylamine. Let me make ethylamine. CH3, CH2, NH2. Okay. So if you see, methyl has got 4 sigma bonds, so steric number 4. Now this carbon in the center again has 4 sigma bonds, 2 with hydrogens, 1 with carbon, 1 with nitrogen. So again, the steric number is 4. And my nitrogen, I can see 3 sigma bonds here. That means 6 electrons are accounted for. Thus, there is 1 lone pair of electron there. So now you have 4, the steric number again being 4. So now we can start with the hybridization here. Let's make, first we make for carbon, then I make for another carbon, and now I make for nitrogen. Okay, the 3 hydrogens here. We are left with 2 hydrogens for the center carbon. Let's make those. This one is carbon, this one is carbon, and this one is nitrogen. So students, the structure is ready for you. I think you must have understood how I am doing it. Okay. Next now, the next structure which I had given you was acetone. So the structure for acetone is CH3, C double bond O, CH3. Okay. Pretty colorful, I suppose. Fine. So this is the structure. Now let us look at the carbon here. The carbon has 4 sigma bonds. So let's write the steric number as 4. The carbon in the center, you can see it has 3 sigma bonds, so steric number is 3. And this CH3 in yellow is again steric number 4. So the hybridization is sp3, sp2, sp3. Now let us look at the oxygen. If you see the oxygen, we can see 2 bonds. So that means we are accounting for 4 electrons, and a bonded atom has 8 electrons. Thus, we need to make 2 more. And now let me calculate the steric number. The steric number is total number of lone pair of electrons plus total number of sigma bonds. So the steric number here is 3. That means it is sp2. Okay, so now let's start making the structure. Carbon, we are first making this carbon. This is an sp2 hybridized carbon. So let me make that. This, and this. This is an sp2 hybridized carbon. Let's make the oxygen now. The oxygen is again sp2 hybridized. So this is the oxygen which we have made. In the oxygen, lone pair of electrons are sitting. So we've made the lone pair of electrons. Now to the carbon, on both sides, tetrahedral CH3s are attached. So let us now make tetrahedral CH3s. I have less space available, so I'm shortening the structures. So this, now let me write carbon here, carbon here. This one is oxygen, this one is carbon. Let's put hydrogens, 1 hydrogen, second hydrogen, third hydrogen, one hydrogen, the other one, and now we have the next one. Fine. Okay. Now let us make the unhybridized p orbitals, one on carbon and one on oxygen. And these two will overlap sideways. So that is how they overlap. And this is the structure of acetone. Hope you've been able to understand it, students. We now come to the next structure. The next structure which I had given you was propyne. So let me make the structure of propyne. Propyne is an alkyne of 3 carbon atoms. Let me make that first for you. Where am I going wrong? So this is propyne. Now let's start making propyne, the structure of propyne. If you look at this propyne molecule, let me make it somewhere else. Okay. So if you look at this structure of propyne, the carbon here, steric number is 4. This carbon, there are 2 sigma bonds for this carbon and 2 pi bonds. For steric number, we only calculate the sigma bond. So steric number is 2. And here, this carbon, again, the steric number is 2. So this CH3 will be sp3 hybridized. This carbon in the center, sp, and this carbon on the side again, sp. So now we have our hybridizations complete. Let me start drawing it. Okay, if I draw the first, let me make the multiple bond. So this is the linear sp hybridized carbon. This is the next sp hybridized carbon. To this sp hybridized carbon, I have a hydrogen. And on the other side of the center sp hybridized carbon, I have a tetrahedral sp3. Let me make that. I'll have to do it again, students. We were making propyne. So propyne, just a minute. Okay. So we were making propyne. Propyne would be CH3, C, triple bond, CH. Okay. So here, CH3 we said was sp3, C we said was sp, the other, this carbon was also sp. Fine. So let us first make sp carbon, the other sp carbon, and then the hydrogen. And now to this sp carbon, there is a tetrahedral carbon attached. Let me make that. I've made that. Now I need to put my p orbitals. First I need to put my name of my atom. So I've put that. Here is a carbon. This has 4 hydrogens attached. Let me make the 4 hydrogens. I've made the 4 hydrogens. Let me do this part again. One hydrogen, the other hydrogen, and the next hydrogen. Fine. And this one is a carbon. Okay. Now on these carbons, the sp hybridized carbon, there are two unhybridized p orbitals. So this is the first unhybridized p orbital which I am making. So this is the first unhybridized p orbital which I have made. And then another p orbital is orthogonal to this first one. So this is the other p orbital. Let me change the color and make. So this is the other p. So there is one pi bond between these two, and there is another pi bond between these two. And thus this is the structure of propyne. I hope, girls, you've understood. Okay. Next structure which we had was aniline, and the structure of aniline will be, let me first make the molecule. Aniline is basically, I have a benzene ring, and to that NH2 is attached. And if you see, the NH2 has a lone pair of electrons, because total 6 electrons could be seen. In benzene, all the carbon atoms are sp2 hybridized, because if you see, we have 1, 2, and 3 sigma bonds. So all of them are sp2 hybridized, and the nitrogen here has steric number 4, so it is sp3 hybridized. So let me write sp3 hybridized for it, and let's start making the structure. So this is benzene. I am first making the sigma bonds so that it will be easier for me to make the structure. Okay, on top of this we will make the orbitals. Now each of the carbon atom is sp2, so that is how I've made. Now this carbon again is sp2. Let me make this sp2 carbon. This carbon is again sp2. Let's make the sp2 carbon. This again is sp2. So let's make all sp2 carbons overlapping with each other. Okay, so that's what we have made. And now I need to put hydrogens there. So these are the hydrogens. And now in place of this hydrogen, what we need to put in place of this hydrogen, there is, we have to put an NH2 group, which is sp3 hybridized. So let us make an sp3 hybridized NH2 here. That is tetrahedral. So I've made an sp3 hybridized NH2. This is a nitrogen. This one is carbon. This is carbon. This is carbon. This one is carbon. Again a carbon, and again a carbon. In nitrogen, what do we have? In nitrogen, we have two hydrogens attached. So I've made the two hydrogens attached, and I have a lone pair of electron attached. So these are the pi bonds which I have made. Now, these are the sigma bonds which I have made. So now let me make the sigma bonds and then the pi bonds. So sigma bonds, if I represent the sigma bonds like this. So I've made all the sigma bonds. Now on each of the carbon atoms, there is an unhybridized p orbital. So let's make the unhybridized p orbitals on each of the carbon atoms. That's how we've made the p orbitals. And now what we need to do, we need to join the topmost orbitals. So I've joined the topmost orbitals, and with another other color, I can join the lower orbitals, showing the formation of the 2 pi bonds. And that's it. That is the structure of aniline. I hope students you have understood that. Now there is another good molecule which we haven't covered, which is known as alene. So I will be doing alene with you. Alene is this. So if you have double bonds on adjacent carbon atoms, it is known as alene. Now, if you look at the structure of alene, this carbon, the first carbon here has got 3 sigma bonds, so it is sp2 hybridized. The carbon in the center has got 2 sigma bonds, so it is sp hybridized. And the carbon on the side again has 3 sigma bonds, so it is sp2 hybridized. Now, let us make this structure. Okay. So let's start with the center carbon, sp hybridized. So I have made the sp hybridized carbon. On both sides, I have an sp2 hybridized carbon. So let me make one sp2 hybridized here and another sp2 hybridized here. That's it. And now I have to place hydrogens. So I have placed hydrogens there. Okay. Now let me write the names. So this is carbon, and this is carbon. And if you see, we need to put unhybridized p orbitals. So this is an unhybridized p orbital on carbon. Similarly, there is an unhybridized p orbital on the center carbon. So that I have made. These two will overlap, so that makes the pi bond. Now, orthogonal or right angle to this p orbital is another p orbital. So let me make that. So this is orthogonal to the first one. Similarly, this one is orthogonal here. So I have made. So this is okay. So now you can see that is the structure of alene. Now, if I have to draw the structure of alene, make the sigma bonds, you will come to understand how the structure is made. Let's see if I make, so I have this carbon, here is a hydrogen, here is a hydrogen, then I have a double bond C. And now if you see, actually the other two bonds are in a different plane. Like this hydrogen bond is going inside the blackboard and this hydrogen bond is coming outside the blackboard. So you can see that this alene molecule does not have a plane of symmetry, because though it appears the molecule has a plane of symmetry, these two carbon atoms are not in the same plane. Here at this carbon atom, this is in the plane of the paper, but if you look at the other carbon atom, the hydrogen and both the hydrogens are not in the plane of the paper. One hydrogen is going inside the blackboard and the other hydrogen is coming outside the blackboard. Students, hope you have been able to understand all these molecules and would be able to now make any molecule of your choice. Thank you. We'll follow it up with other exercises as well. I will keep you informed with more assignments. Thank you, students. This is for today.